Section 5.5 is focusing on inequalities in a triangle. And we're really focusing just within the triangle. There's going to be some inequalities. And let's just remind ourselves, what is inequalities? What are inequalities?
So, like, that's like saying less than or greater than,
Right.
less than or equal to, greater than or equal to. So, no equations today.
Right.
Okay.
So we're going to be looking at these inequalities that exist within a triangle.
Just one triangle, too.
Within one triangle.
Okay.
All right. So just by looking at this first example up here, this first triangle that we have, what side do you think would be the largest side or the longest side?
Okay, so I'm looking here and I can tell like it's giving the angles.
Yeah.
So I could easily say, well, the largest angle is angle A, but you're not giving me anything about the side lengths, and so I'm not going to like assume, well, that one looks longer or that
Right.
one looks the shortest. But I'm kind of what I'm thinking, and I'm hoping you guys are thinking about this too, is I'm thinking maybe segment CB, that side might be the longest.
Okay, what makes you think that?
Well, I'm looking at the angle that's it's across. I brought that up first. The angle that it's across is the largest angle. And so if you kind of get a visual of it, and Miss Hograby's kind of doing this for you, the longer the side, if you don't change the actual side lengths, the larger the angle, the side across from it's going to be longer that connects it.
Right.
If you make it smaller, that angle gets smaller, which means the segment between them gets smaller.
Right. So when you look at these pictures, notice that we're looking at the angle measures, and we notice that 82 degrees is definitely the largest angle. Mm-hmm. Well, the side that's going to be opposite that largest angle will be your longest side.
Okay, so that would be segment CD for that, or CB, sorry.
CB.
Okay, so if I'm just looking ahead, if I think that kind of approach, could I answer that same question similar?
I think you can answer this next one.
Okay, so which angle is the smallest? I don't give you the actual angle measures, but I'm giving the side length. So I want the smallest angle, which means I probably want the side that it's across be the smallest.
Right, because same idea. If I know that side is the smallest, that means the angle is going to be the smallest.
Okay, so if I'm looking, I look at the smallest or the shortest side, which is segment DE. That's that 5. And the angle that it's across would be angle F. So that means angle F is the smallest.
Perfect. All right, so now, do we know exactly what the angle measure is?
No.
Over here for the first triangle, did we know exactly what the side length was?
No.
No, but we can relate which one is the smaller, which one is the larger. Kind of hearing these inequality words.
Hence the inequality, yes.
We're
I
able to see which side is smaller or larger just based off of that.
So kind of a little bit of common sense in a sense.
A lot of common sense. In fact, these last couple sections you're going to notice are a lot of common sense.
Cool.
Now, I didn't say this, but which, in this first triangle ABC, which side, what if I had said not the largest, what if instead of the largest I said the smallest?
Okay, so if I'm looking at which side would be the smallest, I would want to look at the smallest angle, which is angle C, that 35, and the one across from it would be segment AB, so that would be the smallest.
So I know this is the smallest, I know this is the largest, then obviously the other one is the one in the middle.
Yeah.
Okay, let's go back over here. We said this is the smallest angle.
And so if you're wanting
So
the
what would be
largest,
the largest?
so across from the largest side or longest side, that's EF, the 8. So the one across from it, that would be the largest, angle D.
Great. And again, angle E would be somewhere between them.
Cool. All right, now, and I like that you said that. So this angle, so it's kind of a way to check too. When we get to especially chapter 9, we're going to be finding angles and sides of triangles. So knowing kind of what to predict is good to know as well. Knowing, okay, I know angle E, that measure's got to be somewhere between angle D and F. That's a good kind of observation. Now, basically, you explored the first two theorems, okay? So I'm just going to knock out both of them at the same time.
Sounds good.
Neither one of them have names, okay, which doesn't necessarily mean a bad thing. That means that we probably aren't going to use them a lot in proof. It's more just applying them. All right, so this first one is talking about the fact that if you have one side of a triangle that's longer than the other side. Okay, so they're just comparing two sides at a time. Okay, they're not comparing all three like we saw in the last picture. They're just talking about two at a time. So one side of a triangle is longer than the other. So in this picture, notice which side is the longer of the two.
Yeah, AC is larger than or greater than BC.
And notice how I use the greater than symbol. Okay, that means longer in this case because you're talking about the length. So segment AC's length is longer or greater than segment BC's length. All right, so then what are they saying? They're saying then the angle opposite the longer side. All right, so the longer side is
the AC. So across from that is the angle B.
So that means that is that is larger than the angle that's opposite the shorter.
Okay, so then the measure of angle B is going to be greater than the measure.
Okay. The measure of angle B, sorry.
That's okay.
Is greater than which measure?
The measure of angle A, which is across from that shorter side.
Okay, now that doesn't communicate what the actual measures are. We just know it's going to be smaller than, or angle B's measure is going to be larger than angle A, or angle A's measure is going to be less than angle B.
Right. It's just the relationship.
Yeah. Do we know anything about angle C in this picture?
Not at all.
No, because we don't know anything about the side it's across.
And we're not going to assume.
Nope. Okay. So, and this kind of goes also with the shorter also as well. Like you could relate this. It just doesn't say that.
I'm guessing the next theorem must do with angles.
It does. So kind of reverse of it. So if you have an angle that is larger than in a triangle, larger than another angle. So in this case, we can look and see that angle C is obviously larger than angle B. Okay?
Right.
Then what can we conclude? It says that the side opposite the larger angle, so which side would that be?
Side AB.
Because this is the larger, so side AB's length is going to be longer than the side with the smaller of the angle. So that would be
going to be greater than the segment or the measure of AC.
Okay, so this is across from that, right? So again, you're just relating one angle to another, which means then you can relate its opposite side with the other opposite side. Now, this brings up also a little point here. We've talked about this before. If I give you two angles in a triangle, can you technically find that third angle?
Yeah, we could.
Okay,
because we know the triangle sum theorem.
Yeah. So if if you add these 45 and 60 together, you get a total of what, 105 degrees, and you subtract that from 180 and you get what?
170 or 75.
75.
Yeah.
So now you could technically relate that angle with the others and the sides with the others, but they're just in this theorem just relating the two that are given. But this could help. Okay, so if you ever have two angles in a triangle, go ahead and find the third, because you might be able to use that to answer some questions. All right.
Okay, so we've got a couple of examples on this one. Notice the first triangle up here has got what kind of measures?
Side lengths.
And the second one has some
angle measures.
But we know how to work with either one. Our job here is to write the measures in order from least to greatest. Obviously, we're not writing the measures of the segments that they give us. We're writing the measures of the angles, the unknown parts. All right, so let's go ahead and let's talk about this first triangle, this triangle ABC. So we have the sides. We don't need to worry about listing the sides in order. You can if it helps you.
Yeah, it could if you wanted to talk about the opposite type things.
Right.
Okay.
But we need to look at what's across from them.
Okay.
So we want to go in order from least to greatest. Which side here is the smallest side?
AC.
So if AC is the smallest side, when I talk about the smallest angle,
it would be angle B. So that measure of angle B would be the smallest.
Yeah. And because they're wanting us to put their measures in order, we're listing it as the measure of angle B. Okay. Now, which is the next smallest?
Side AB's length is the next smallest, so the angle across from it would be the measure of angle C.
Perfect. And which then would be the largest?
Angle A, which is what's left.
Exactly. Hopefully at this point we're good with finding that third angle, because it's your only other option. Again, we're talking about their measures. So this measure is technically smaller than this measure.
Uh-huh.
And this measure is also technically smaller than this measure. We could write, because this whole section is talking about inequalities, you guys have learned how to write compound inequalities when you were in algebra.
Okay.
We could technically say that the measure of angle B is what compared to the measure of angle C?
A little smaller, so less than the measure of angle C, which is also less than the measure of angle A.
Yeah. So we could write this as one large compound inequality as well. They just ask us to write them in order. So really just with commas is fine.
Kind of listing
But
it.
I want you guys to realize that these are really compound inequalities. So it's kind of tying in some algebraic skills that you guys learned before too.
Cool.
All right. Next one. They give us angle measures, but they only give us 2.
I can find that third.
We can find the third.
Okay, so if I add up the 111 and the 46 together, that's what, 157, right?
Uh-huh.
And then if I subtract 180 or 180 minus that would be 23 degrees.
23, exactly.
Okay. So that would be angle V.
Perfect. Now, we have all of our angles.
Okay.
So let's start with what is the smallest, since we're doing the smallest to greatest. Yeah,
Uh-huh.
least to greatest. What is the smallest angle that we have here?
That was angle V. And you have to, and obviously we had to find that. You can't say, well, it looks the smallest, and we tried to make it kind of look small, drawn to scale,
Yeah,
but it
but
doesn't always.
We do not. In fact,
No.
sometimes we purposefully try to not draw them to scale.
Yeah.
So that way we make sure that you guys
So
know
you
your
found
content.
that means the measure TU is the smallest. Then I go to the next, which would be that angle U, across from that would be TV. And then finally UV is my last.
And could I write this then as a compound inequality if I wanted to?
Yeah, so I could say TU is less than TV, which is less than UV.
Just be careful if you do try to write, especially when you're doing angles. When you try to do angles and you also have less than symbols in there, it gets a little confusing sometimes. I don't know if you guys noticed. I tried to, like, the measure of angle B, I try to keep kind of close together, but then I spaced it out between the less than sign, just to notice that I'm not saying the measure of angle B, angle, measure of angle C, angle, measure. I don't want you to think those are angle measures.
So if you were asked to write this, would we need to do it as a compound inequality? Or
no, not this.
Okay.
Because that's not, they just asked you to list them.
Okay.
But I just want you guys to realize that if you do want to list them,
There's an option.
there is an option.
Okay, so here's another scenario, and this one I've already noticing that there's actually 2 triangles in the picture. So when we're talking about these 2 theorems, you're talking about in one triangle. So you kind of have to think about that kind of starting with one triangle at a time. It says list the sides in order. So again, we're going to kind of do what we did there. Notice it doesn't say measures this time. So you're talking about the sides, which are segments, from the shortest to longest.
Okay.
Okay, so we're going to basically do least to greatest like we did on the last one. Now, I see that all the angles are already provided, and that's what's going to relate to the side lengths. Okay, if I give you all the side lengths, well, that would be way too easy. Okay, so we're having to start with the smallest angle. What are you noticing?
Well, I know that there's 2 angles that are both 30 degrees. So does that mean that those 2 sides opposite are going to be the same?
So, in other words, you're saying the side
So
opposite,
like
AB.
AB and BC, does that mean that those are the same?
Nowhere does it say that the side across from an angle is the same. And if you think about it, notice how, like this one, this side BC, is actually related into both triangles. Do you see that?
Oh,
Do you
yeah.
see how side BC, and I might change the color here, notice how segment BC is involved in both triangles.
Right.
So BC is across from the smallest angle in this triangle, but it's actually across from which angle in the other triangle.
Oh, the largest angle.
So it can't be the same measure as AB. So you got to think about this and don't overanalyze this.
Okay. So maybe we just need to look at each triangle individually.
Yeah. So if it's across, if B segment BC is across from the largest angle in this triangle, triangle ABC, but it's across from the smaller angle in this triangle, does that mean BC is the shortest side out of all of the sides?
Probably not.
No, because it's actually across from the larger angle in this
Right.
one, so it can't be the shortest side.
Okay.
So we need to make a decision of of which triangle maybe we're going to start with.
Okay.
So which triangle do you think we would start with?
Well, I'm thinking, because I wanted to start with shorter sides, it looks to me like triangle ABC, those sides are maybe a little shorter than some of them in BCD.
Yes.
So let's start with that triangle. And I think, okay, so just starting with just that triangle, I'm looking at those sides and I noticed that 30 is the shortest angle. So at the side across from that, AB, segment AB now, because we're talking about the sides. Segment AB is definitely the shortest side.
Now, I want to piggyback on what Ms. Huckerby said. She said, starting with ABC because it looks smaller. Obviously, we don't ever want to base off what it looks like. But in this case, I mean, we kind of try to help you out there. But the other thing to keep in mind, if I started with the other triangle BCD, then we would start with BC, where BC is not the shortest side in this triangle ABC.
Right.
So
and
that's
guys, if you did start with that, you would realize later.
Yeah, exactly. So, and this is one where I say, don't overanalyze it. Really don't. Okay. Just kind of use common sense.
Okay.
All right. Common sense.
As I'm looking at that, okay, so AB was definitely the shortest side. Then 68 is the next smallest angle. So I'm looking at AC, segment AC being the next shortest. Right. And so the only other side left in that triangle would be BC.
Okay.
All right.
So we took care of that triangle. So now we got to go to the next triangle.
Okay. So now let's take a look at, for this triangle, okay, the 30 is the shortest, or the smallest angle. So the shortest side would be the BC.
And notice that I already listed that.
Okay, so yeah, I don't need to relist it again.
Yeah, and that's what, do you see how the cool connection, where the smaller triangle, kind of the largest side, was the smallest side in the next triangle. Okay. So that's why, like Ms. Huckerby said, she said even if you started listing them, you would have seen that connection.
Yeah. You would have seen that you were listing BC a second time. And
yeah, you don't want to do that.
In order. Okay. After the BC, after the 30, 65 would be the next smallest angle. So CD, segment CD would be the next one. And then, of course, the only thing that's left would be BD.
And notice you're listing, notice how many segments are in this picture. There's only 5 segments technically because they share a common side. So that's why you only should have 5 listed.
So when we see that sharing of that common side, it probably is maybe the shortest of one but the longest of the other.
Exactly.
Okay.
Love that you said that.
All right. Triangle inequality theorem. This says the sum of the lengths of any 2 sides of a triangle, so the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. Okay. Now, I'll tell you guys that this one, there are several inequalities that we can technically write with this.
Yeah, because they're just saying sum, so adding any 2 sides, and there's 3 sides in a triangle, so we could add 2 of the sides.
Add the first 2, the second, the third,
exactly.
etc. So just to kind of show what this is saying, that let's start with segment AB. This measure of segment AB plus the measure of segment, let's go with, AC.
Perfect.
So the sum of the measures of 2 sides of a triangle will always be
greater than that third side.
So greater than
BC.
Okay, now, just kind of and there's other inequalities that we could write even.
Let's do that.
Okay, what are the other inequalities?
So let's do AC and BC. That has to be greater than AB. And then I'm thinking of one more. BC plus AB has to be greater than AC. So there's technically 3 different inequalities you can write from this inequality theorem.
Exactly. And I just want you guys to think about what this is saying. So this is saying that, okay, I've got a segment length, and I'm just going to write them all out, kind of just, I'm going to tear it apart. It's not going to look like a triangle anymore. Okay? But I've got 2 segments that together, when I add these 2, so if I did a little segment addition postulate and made them all one segment, one big long piece, okay, adding those 2 together, that measure has to be greater than the third side. And I just want to show, what if they were equal?
Okay.
Okay. So now if I took this segment and I went ahead and, I don't know if I can rotate it on here. Can I rotate it? Oh, it's not letting me rotate it. Okay. I'm just going to do this, but I know it's going to change the side a little bit. If I rotated it up, could these ever, if laying flat, they touch that third side.
Yep.
Then if I start to rotate them up, will they meet?
No, they're never going to intersect.
They're never going to intersect.
Which means it wouldn't make a triangle.
Right. So together, the sum of two lengths always has to be greater than the third side. Because if they equaled the third side, they wouldn't even touch. And think about it. If the sum of them did not even equal the third side,
So
if they were less than, there's no way they would ever touch.
So this, what I'm kind of noticing is that this kind of allows you to decide if you can even form a triangle with certain measurements.
Right.
In a sense.
Exactly.
So I can't just give you just 3 measurements and call it good.
Right. So like if I said, would 1, 2, and 10 make a triangle?
No, because 1 and 2 don't add up to be greater than 10.
So it's not greater than 10. Right. It's only
Yeah.
3. And that would be an example where, again, if one side was only 1 and one side was 2, they're definitely not going to ever form that triangle to make the whole,
Okay.
to meet.
Cool.
Okay.
Well, and Ms. Hogravy kind of gave us a little preview of the next slide. That's exactly what we're going to do. We're going to decide if it's possible to have these particular lengths to make a triangle, right? And this is actually, guys, this theorem is something, and I mentioned earlier about the chapter 9 with right triangles. You're going to see this again in that chapter because sometimes we'll throw out 3 measurements and there you have to first decide even if it makes a triangle. So looking at this first scenario, all right, if I give you 3, 3, and 8, could these actually make and form a triangle? So the way to determine is any 2 sides have to add up to be greater than the third, right? So if I add up these first 2 sides, 3 plus 3, is that greater than 8? That's really the question, right?
Right.
Well, 3 plus 3 is
9. So yeah, that's 9.
careful.
3 plus 3. That's hilarious. 3 plus 3 is 6, and that is definitely not greater.
Yes.
Than
You
8.
know what's funny is I was thinking you were going to say 3 times or 9, and that would have worked in. So not the product.
That is such a common mistake.
And so 6 is obviously not greater than 8. Now, do I need to check with the other scenarios? Like, do I need to check and do 3 plus 8? Is that greater than that third side?
Well, I wouldn't think so. I've already proven that it's not going to be a triangle.
It's not going to work, right?
If it doesn't work for one case,
this
it's
would
just
be
not gonna work.
a no. Okay? So
Okay.
looking at the next scenario.
This time
all
we're
right?
going to add.
Yes.
Okay.
So we're going to, and here's the deal. You can add any 2 sides. I just tend to pick the first 2 because it's right there. 6 plus 5, is that greater than 12? Well, 6 plus 5 is
Ooh, it's 11.
11. Is that greater than 12?
No.
No. So I don't need to keep going. This is a no. All right?
Okay.
The last one, so let's pick 2 sides. I'm going to pick the first 2. Is that greater than 11? Well, that's
14, and yes, that is greater than 11.
okay. So doesn't mean it works for all scenarios.
No, I probably need to check the other ones
You need
too.
to check.
So kind of thinking about that idea of a counterexample. If you have one counterexample, you've really shown that it doesn't work. But if it does work, you need to show it works for all cases.
Yes. Like, for example, on this one, I could have added the 5 and the 12 together to see if it equal or is greater than 6. Well, 5 plus 12 is 17. It does work. But notice we have a counterexample. So it's got to, again, like you said, work on all cases. So let's add the next 2 sides, like 5 and 11. Is that greater than 9? Well, that's 16. Is 16 greater than 9?
Yes.
Yes. All right. And then the last scenario is 9 and 11. Is that greater than 5?
Definitely.
Right? That's definitely.
20. It's greater
all right.
than 5.
So that checks out. So this would be a yes. So you want to kind of show all scenarios work on one that's a yes.
Yeah.
When it's
In
a
fact,
no, just one.
we're
thing.
expecting you to show
Yes.
that all of the
So when
scenarios
it's a
work
yes, show all cases. It's kind of like you're proving it. Okay, not just one. When it's a no, you just need one counterexample.
So I'm noticing that if I pick the smallest 2 sides, that kind of seems like that's a good approach to a way to start this. Because if the 2 smaller sides do not add up to the larger side, that's going to be a dead giveaway that it doesn't work.
Exactly.
Because if I'm taking one of the larger sides and adding it with a smaller piece, of course it's going to be larger than something that's smaller than that too. So really looking at adding the 2 smaller pieces first is maybe a good approach.
And well, part of it is it helps with the no's because then
I
it's
don't have
less
to find
work.
more pieces.
But again, when it's a yes, we do want to see kind of you support it, okay? Support what your thought process is.
Okay. The next question says a triangle has one side length of 8 centimeters and another that's 17 centimeters. Describe the possible length of the third side. Now, one thing that this doesn't have is what?
A picture.
Now, it may be helpful to have a picture just to get a visual. Keep in mind, though, that we have no idea what that third side is. So when you're drawing a picture, if you do that, just keep in mind your picture may not end up being drawn to scale.
And that's okay.
And
It's
that's
just a
okay.
sketch.
So if I just say, okay, I've got a side that's 8, a side that's 17, and obviously mine is purposefully not drawn to scale because I know it's not going to be in the end anyways. We want to figure out what is this third side.
Okay.
Okay? Now, when we have unknowns, what do we typically use?
Use variables.
So let's go ahead and let's call that what?
Let's call it X.
Sounds great. All right. Now, looking at these sides, I need to figure out, I know that I want it to be a what?
We wanted to make a triangle.
We want it to make
Like
a
it
triangle.
has to be.
It has to be a triangle. So therefore, we can kind of think of this whole triangle inequality idea to help us
okay.
to be able to come up with these possible side lengths. All right. So what do we know about the sides that we do have here listed?
Okay, well, I like that you said that triangle inequality theorem, because kind of thinking back to that, that means any two sides added together have to be greater than the third. So if I add, like, let's say 8 and 17, that has to be greater than that third side, which we labeled as X. So that means if I add those, that gets you 25. That has to be greater than X. Now they're saying describe the possible lengths of the third side. So I might want to write it as X is less than 25. So saying the third side has to be less than 25 centimeters.
Perfect.
So does that mean any length that's less than 25 centimeters will work for that?
Probably not, because you could have a length of maybe 1 and 8 together are not greater than 17. So
Or even like a negative number.
yeah, you could
Can't have a negative
definitely
length,
can't have
right?
negative length.
Okay.
So let's think about another boundary.
So I like that. I was going to say that, a boundary. So we're going to kind of restrict what we can have. So what about if I do add up like the 8 and the X together? And that has to be greater than the 17, the third side. And I go ahead and solve that, subtract the 8 on both sides. I get X is greater than 9.
Okay? So X has to be less than 25. Right now we know X has to be greater than 9. But there's another inequality I could technically write as well.
Okay. The other one would be the X and the 17 added together is greater than 8. When I solve that, I get X is greater than negative 9.
Now, you kind of already mentioned, can we have negative side lengths?
No, and something like that would be like negative 8 is greater than negative 9. Well, you can't have a side length that's negative. So that
Right.
probably isn't going to help us any.
Now, I'll tell you that when you're writing these, when you're looking at this, if it is something, we already found X has to be greater than 9, right? Mm-hmm. So if X has to be greater than 9, and here we're saying X has to be greater than negative 9, well, anything that's, you can have numbers that are greater than negative 9 that are still less than 9.
Mm-hmm.
We know X has to be greater than 9. It has to meet all of the criteria.
Okay.
We can't just pick and choose which ones we want it to meet. It has to meet
Gotcha.
all of these. But would you agree that things that are greater than negative 9, that there are also some, they probably also could be greater than a positive 9 as well.
Well, they are, yeah.
Right.
A lot of them are.
A lot of them are.
The ones that would make sense to a side length.
Exactly.
Mm-hmm.
So when you're looking at this, you're going to notice that one of your inequalities, not super uber helpful.
Yeah, and
Okay.
that one doesn't help at all.
This one not helpful at all. So when you're looking at this, you want to make sure that your side lengths have to meet all of the criteria.
Okay.
So anything that I choose that's greater than 9, it's also going to be greater than negative 9.
Okay.
True. But these are going to be the ones that are going to be helpful for us.
Okay.
So now, I kind of mentioned before this whole idea of a compound inequality. And this is really why I mentioned it, because I wanted us to, when we get to this phase, be like, oh, okay, we can write this compound inequality. And if you look at this, we have 2 restrictions for X. It has to be less than 25, but it also has to be greater than 9. Now, I remember when we were in Algebra 1, we wrote compound inequalities, and we put the X in the middle. And we
Yes.
tried to compare it to 2 separate things. And I at least always have my students start with the smallest value. Mm-hmm. So
Well, that would make sense.
Right. We're going to say that 9 is something compared to X, which is something compared to the 25.
So I know that you're comparing x to 9. X is greater than 9, so that means 9 has to be less than x.
Right. Again, thinking the alligator eats the bigger number.
And then x is less than 25.
So x has to be a number between 9 and 25.
That makes sense. So like 10, 11.
All of those could work.
13.5, any of those.
Notice it says describe the possible lengths. That means that there's more than just one.
Okay.
And so that's what we're describing. And that description is, I love the fact that we can just use a compound inequality to describe it.
All right. Okay, last scenario. It says find all possible values for x. All right, now this time they're not asking you find the possible length, side lengths. They're asking what values of x could make this true. Now, x, notice, is part of a side. It's not a full side. It's like this one says x plus 2. This
Part of each of the sides.
Yep. It's in all 3 sides. Now, the fact that they're talking about what's the possible values of x, that means you're going to have some boundaries, okay? You don't really know actually how long each of those sides lengths are, but we know we're restricted. Okay, in a triangle, every 2 sides have to be added up to be greater than the third. So this triangle inequality theorem, all right, will probably be used in this case.
Okay. So is it going to be like the last one where I'm going to have 3 different inequalities?
Yes.
Okay, so here we go. I'm going to say that the first inequality that I could write would be maybe an x plus 2 plus our x plus 3 is going to be greater than our 3x minus 2.
So what she's doing is she's adding side AB to AC and saying that's greater than that third side. So there's one scenario. I'm just going to even number that. That's my first scenario.
Okay.
We'll go back and solve it. Let's get the other 2 set up.
Okay, so the next scenario, let's say, how about my x plus 3 plus my 3x minus 2 has to be greater than that side of x plus 2.
So she's adding this side to this side, and it has to be greater than that third side.
Okay. And the last scenario would be that our 3x minus 2 and our x plus 2 together will be greater than our x plus 3.
So this one and this one add up to be greater than that. So our 3 scenarios, because all 3 scenarios, in a sense, have to work for it to be a triangle. We knew that. Now, we learned from the last one that sometimes they're not all helpful. All right?
Right.
The last one, only 2 were helpful. Sometimes maybe only 1 is really helpful. Sometimes 2 are helpful. It just kind of depends.
Okay.
So this is where, once you solve it, you do the algebra, and most of you are good with solving and doing the algebra, but you also have to keep in mind, you got to think about also common sense.
So we have to interpret it well.
Yeah, exactly.
Okay.
Apply it in a sense. So let's go and solve this. So we solve
And I really
this.
like that we wrote all the inequalities before we start solving, because I think I might lose track of which ones we didn't cover yet.
Exactly. I like that. Just get them set up and then go ahead and solve it. So I'm going to go ahead and combine these. So this is 2x plus 5 is greater than 3x minus 2. What would you do next?
I would go ahead and move all the x's to the same side. So now, because I know I want to compare things with x started first, we could move the x's to the left side.
Okay.
But then I know I'm going to have to divide by a negative, and don't forget, if you do that, when you divide by a negative, we're going to have to flip the inequalities.
Okay. So let's just do that. If
Let's
I
do it just so we remember that.
So if I subtract 3x, I'm going to get a negative 1x. If I go ahead and subtract the 5, let me go ahead and do that.
Yeah.
And then if I divide each side by negative 1, I end up with x is
less than
7.
So just don't forget that when you're dividing by a negative, flip that inequality symbol too. If you do that approach. If you wrote it the other way and just got all your x's to the other side, you would have gotten that 7 is greater than x, which you could then rewrite if you wanted to too.
Same difference.
Yep.
All right, next one. Go ahead and combine.
Yeah.
So what, 4x?
4x plus 1 is greater than our x plus 2. So let's go ahead and say that 3x is greater than a 1. So x is greater than 1/3.
Okay, so a little bit of fractions, but we can deal with that.
Next one, I notice we've got a 4x. Ooh, the 2's canceled totally. Is greater than our x plus 3. So 3x is greater than 3. So x is greater than 1. Okay, I'm looking at these, and I see that we've got an x is less than 7, and that's the only less than that we have. So that means that x has to be something less than 7.
So that's kind of your upper bound in a sense.
Right.
Okay, so that probably is one we're going to use. So I'm going to use that one. I might even make a note that this is going to be, x has got to be less than 7, we might have a lower bound as well. Because we know if something's less than 7, that can include negatives, like negative 10. If I put negative 10, which is obviously less than 7, if I put negative 10 in here, negative 10 plus 2 gets you a negative 8, which you can't have a negative side length.
Right.
Again, x is not the side. X is part of the side.
Right.
All right, so we're looking at these two.
So we've got x has to be greater than a third, and it has to be greater than 1. Now, I'm just going to kind of reason in my mind which one I think. I believe that it has to be greater than 1.
Okay, why is that?
Because I know that x has to be, we said it has to be greater than a third, and it has to be greater than 1.
Okay.
Well, everything that's greater than a third, that 1 starts in that category as well.
Okay.
Okay? But if I said that it just has to be greater than 1, and then I try to go back and say, well, what about those things that are greater than a third? Again, they're kind of included in that. And if I look at things that are less than 1 but still in that greater than 1/3 category, they don't meet that greater than 1 criteria.
Okay.
I don't know if that may be clear as mud.
Yeah.
I don't know.
No. And I'm going to show you kind of also kind of
visual
thinking of
helps.
a visual. You know, if we go back to Algebra 1 and we graphed our inequality on a number line, so 1/3 is right here. 1 is a little bit obviously bigger. Greater than 1/3 is like that. Greater than 1 is like that. So what Ms. Hoker was saying is like all of this stuff has stuff in common. All right? It's the stuff kind of in between that obviously is different. But the fact that this inequality right here has to happen, all right, that means if you say that, that includes part of that greater than 1/3 in a sense.
Right.
All right.
And if I include the things that are between the 1 and 1/3, then now they no longer meet that last criteria of being greater than 1.
The stuff in between here does not meet the stuff here. So then that means this one is not the one you like.
Right.
Now, another way to kind of do this is you could check it, right? And this is where if this is not making maybe sense here, I think I'm going to think of a number that is between 1/3 and 1.
Okay.
Okay, so not including 1/3. Okay?
So maybe like a half?
A half. So if I put a half in for x, okay, a half in here, that's 2.5. That works. That could be a side. If I put a half, that would be 3.5. If I put a half in here, 3 times a half is 1.5. But 1.5 minus 2 is a negative 1/2.
Ooh, okay.
Can't have a side like that's negative 1/2.
And that's why that other restriction kind of limits that.
So if you need to, you can always check to kind of see that. Or also think about what Ms. Hoke-Gravy said. There's a variety of ways to kind of think about that. All right? Just, do what is best for you. Okay, so we know for a fact we're using this one, and we're going to use this one. So if this x has to be less than 7, we kind of remember that compound inequality. X is greater than 1. So if I want to compare that, so 1 is less than x, but it's also less than 7. So somewhere between 1 and 7.